In this episode, we are going to look at problems on centroids of composite shapes. So, a situation whereby two or more simple shapes are combined. How do we find the center? Straightforward, let's look at an example. So, we have this T shape and we are to determine the position of the centroid C of the area below. So this is the shape with the dimensions given, and we are to determine where the centroid C will be. So C means a point where a single force resultant can be placed to balance the body. Are we okay? So since this is a composite shape, first we have to divide it into the number of simple shapes we can obtain. Looking at this, we can get two simple shapes from it. When I close this place, I'm going to get plane 1 and shape 2, right? Which they are all rectangles. Are we okay? And now you check the position of the axis. This is the y-axis and this is the x-axis. Looking at the y-axis, it is dividing the plane into two equal parts. Are we okay? The y is dividing the plane into two equal parts, but the x is not. Sometimes the y is somewhere here at the end of the plane, but here it is dividing, meaning there is no x distance to be moved. The x distance is 0. When one axis divides the plane into two equal parts, that you can see, meaning the other axis is 0. So this is y dividing the shape into two, meaning the x is 0. If the x was the one dividing the plane into two equal parts, meaning the y will be 0. Because here there's no way you have to move on the x-axis to determine the center of this plane, that's plane 2 or figure 2, or you have to move any x again to find the value of x. It is already at the center, meaning we have to check for the value for the y component. Are we okay? Alright, so first we can use the table approach where we can have the number of shapes and the xi bar for each of them, the y bar for each of the shapes, and the area for each of them. So this is what we have. How many shapes do we have? We have 2. So shape 1 and shape 2. So we can determine the various parameters. So looking at shape 1, what is the area? So area for shape 1, which is, this is a rectangle, and that will be the length times the breadth. So 1000 multiplying the 12, and that is going to give me what? 1200. So 1200, this is in terms of millimeter square for area 1. What about area 2? So area 2 is also having the length of 12 and the width of what? 100, the same measurement. So that is going to be also 100 multiplying 12. And it is also going to give me 1200 millimeter square. Now, let's see if we can, on the x, we can get a distance to position the first shape. Looking at shape 1, this is the axis of y, where I have to move either this way or that way to locate the middle for the plane 1. But the axis is already in the middle, so there's no way I can move, meaning there's 0 what? Distance. The same way plane 2 or figure 2, it is in the middle, so I cannot move any x distance, so it is also 0, meaning you can neglect it whenever it is 0. Are we okay? So the y component for shape 1, how do I get to the midpoint of this? it is 12 rectangle, so I have to go half of it to locate the midpoint. So I will move all the way from the axis up and get half of the 12, which is 6. Is that good? But remember, before you got the 6, you moved through all this distance. It must be accounted. So this 100 will be accounted from the axis. So 100 plus the 6. So on the y for the 1 was 106. So for shape 2, I want to locate the middle. It is 100 millimeter long. So definitely the middle will be somewhere 50. So that will be 50. So these are the parameters we will be needing them. This is in terms of millimeter. This is in terms of millimeter. So once we have these parameters, we know our formula. Since the x component is not of interest to us again, our y component is going to be, we know that the formula is x1. So sorry, this is for the y. So we are going to consider the y component, which is y1 area 1 plus the y2 area 2. Everything on summation of the area 1 and area 2. Therefore, the y bar is going to be, what is the y center for the first figure? 106. So that's 106 multiplying the area 1, 1200, plus the y distance or y center for shape 2 is 50 multiplying the area 1200, all divided by the total of the area, so 1200. So from this, then our y bar is going to be 78 millimeters, meaning when you move with this, you move the x as a 78, let's say somewhere here, it will divide the plane into what? 2. So this, therefore C is equal to 0 because the x is already there. Then the y will be 78. When you plot this, you are going to locate the center. Hope it's clear. Yes. Example 2. So here we have another shape here where we are to determine the position of the centroid. Look at this carefully. How many shapes do you see? 2. A rectangle and a cutout circle. Supposing this was just the rectangle, you could just locate the center, half of the 20, which is 10, half of the 10, which is 5, and you'll be able to locate the center. But no, it is composite shape. There is a circle cutout. Are you okay? So meaning initially it was going to be the x was 20, so 10, the y 5. Since there is a cutout from it, now this shape is going to reduce this distance. If initially the rectangle was 4, this was where the weight was going to concentrate, but now they've cut some portion away, meaning you have to shift this to a certain position, meaning after that your answer should be less than these values. Let's check out if it is true. So first, using the table approach, I'll get my shape, or then the area, I'll get my x bar for, and I'll get my y bar for each of the shapes. I have 2, 1 and 2, where I can get everything. The table approach is quite simple, so I prefer the table approach. So for area 1, I'll consider the rectangle as my first shape and the circle as my second shape. For area 1, that will be the length times the breadth. That's 20 millimeter by 10 millimeters, and that is going to give me what? For the area, 200 millimeter square. So the area is in terms of millimeter, square, this is in terms of millimeter, and this is in terms of millimeter. The area 2, this is a cutout plane figure. Remember, any cutout figure is what? Negated. The area is negated, negative area, because we are cutting it out. So meaning the area is going to be, this is a circle, pi r square, so negative, where we have our r to be 2. So that is going to be negative pi 2 square, and the area is negative 12.57 millimeter square. So I have my area for 1, I can fill it 200, and I have this as negative 12.57. I'm going to locate the x center for plane 1 and plane 2, the same for the y centers. So considering figure 1, what is the x center? Forget about the cutout, just consider the entire figure for figure 1. So for the x, since the axis is, I have to move a certain distance on the x to locate its middle. So I will have to move how many? For the x, it is 20. So I'll have to move 10 to get there. So that will be 10. What about the circle? How many, or by how much should I move to get to the center? Remember, to move from here and get here, this is 18. The entire 10 is 20, and there's a radius here where you are not going, which is 2. So when you subtract this 2 from the entire 20, you are going to get, and the x distance for this is going to be also, we consider this to be 18, because you have to move all this way to get here. Is 18. Now let's look at the y component for figure 1 and figure 2. By how much should I move on the y axis to get to the middle of plane 1? It is 10, so I have to move by 5 to get there. And for the circle, I have to, this is 10. So to get here, you subtract this small distance, which is radius 2, and that is going to be what? 8. Is that true? 8. So now I have my table, and I can find the x bar, the entire x bar for the figure, from the formula x bar of the first shape, area 1. Remember, the second shape is a negative area which will affect it. You have to sum them. So negative x2 area 2. This negative is coming from the area 2, which is negative everything on area 1 minus area 2. Are we okay? So when you put in the values, you are getting 200 by 10 minus, this is going to be 18 by 12.57. Everything on 200 minus 12.57, and your x bar for the composite shape is going to give you 9.46 millimeters. You see that the x, originally, if there is no cut, it should be 10, but once you've cut it, the weight should shift, so it is less than this normal 10, which is 9.46. What about the y bar? That is also going to be y1 for the shape 1, area 1. The negative, that is supposed to be a y2. So I have y2 area 2, everything on area 1 minus area 2. When you plug this in, you are going to get 5 multiplying 200 minus 8 multiplying 12.57, the summation of the area, which is that. And when you punch this, your y bar should give you 4.7 something, which is approximately 4.8 millimeters. Therefore, the centroid of this figure, x bar, y bar, is giving us 9.46, 4.8. So you see that it's less than the 10 and the 5. So that's for example 2. Let's look at the last example and determine the centroid. So determine the position of the centroid C of the area below. So the same approach, a very simple way to determine that. So these two, how many shapes can you obtain from this? I can get 2, where I get that as shape 1. I get this at shape 2. Do you see that? Okay, so here too I'm having my shape 1 and 2. Let me do my area in millimeter square, xi in millimeter. Then I also have my yi in millimeter. You do them nicely like that. So for area 1, looking at the first shape, so now this is the axis. It is the axis. None of them is dividing any of the figure. It's not symmetrical, so I have to calculate for both. Are you okay? So area 1 is still a rectangle. This is 7 by 104. Are you okay? So 7 by 104, and that is going to give me 728 millimeter square. That's for area 1. Then area 2 is also going to be, look at area 2, this entire height from here to that place is 104 as well. But area 2 is starting from this point to that place, and we know this small distance to be 7. Therefore, this will be 97 millimeter. So area 2 is going to be 97 by 7. 97 by 7, and that is going to give me 679 millimeter square. So I have the area there. So this is 728. This is 679. Let me locate the center of each of the simple shapes. So shape 1, how do I move to get the x distance? So right here I have to move on the x. This is 104. So to get to half of it, I will move a certain distance, and that is what? 52. When you move 52 on the x, you get the center of the figure 1, right? So figure 2, how many times, or by what should I move on the x to locate its center? Remember, it is 7 millimeter from this, so half of it is going to give me 3.5. Let's look at the y component. This is the first shape. By what should I move up to get to its center? To move up, this is 7, and we're going to get 3.5. But remember the entire distance you covered moving. So this is going to be 97 plus half of this, which is 3.5. And that is going to give you 100.5, right? The same way, if I'm to locate the y component of the figure 2, this is 97. To locate half of 97, that is 48.5. So once you fill your table, you are good to go. The same formula holds, which is x bar is going to be, for the x, this by this, the 52 by its area 728. There is no cutout, so it's just addition, and 3.5 by its area 679, everything on summation of the area, which is 728 plus 679, and this is giving me an x of 28.59 millimeters. You consider the y2, which is going to be y of the first 100.5 multiplying its area 728 plus 48.5 multiplying its area 679 on the entire area 728 plus 679, and with this your y prime is giving me 75.41. Therefore the centroid C is x, which is 28.59 millimeters, comma y 75.41. Remember, in the second video for composite shape, we said when two shapes, you are to determine the centroid for two shapes, it will lie on a line which is connecting the center of the two. So let's say this line is connecting the center of the two. It will lie on this line. Let's try to plot this. So 28, you have to move a certain point here because this entire thing is 104. So 28 will be somewhere here on the x, and the y is going to be 75. So this entire thing is 104. So 75 will also be somewhere here. So when you trace this and you trace that, this is not drawn to scale, you see that the center will lie on a point that is joining, or a line that's joining the centers. Thank you for watching this episode. Watch out for another set of problems that will be involving. Thank you. Subscribe and share the video.